Hello class. In this video we want to go over the application problems for normal distributions. There are two kinds of problems of the normal distributions. Actually there's another one, but we call that central limit theorem, but we'll talk about that in the other video. But we have finding probability problem, and the other one is the finding actual measurement problem. So I'm going to go over those two problems, and I'm going to draw some graphs so you guys can see this. Okay. All right. Let's look at the number one. The problem here is that we have a Beanstalk Club, social organization for the tall people, has a requirement that women must be at least 70 inches tall. So what percentage of women meets that requirement? Women's height is normally distributed. Use population mean is equal to 63.6, and population standard deviation is equal to 2.5. Alright, so what we're going to do is we are going to take the snapshot as we talked about in class. We are going to plot the information first. Okay, so I'm going to do that on this side here. So let's just do that. Okay. Alright, so the mu is 63.6, and the sigma is equal to 2.5 inches. Okay, so I'm just going to write that here. Okay, we want to find out what is the probability that if you go out on the street, you select one female, and then you find the probability that her height is going to be greater than, right, 70 inches. So right here, we want to look at this area here. Okay, alright, so now we want to write it as a symbol. So P x is greater than 70. So we set up all the information onto the normal distribution there. So this is the normal distribution. And now we have to go to the standard normal. Alright, so now we're going to draw the standard normal here. And standard normal, mu is 0 and sigma is 1. So now we have a conversion factor that we talked about in class. So z is going to be equal to x minus mu divided by sigma. So here x is going to be 70, and mu is a 63.6, and divided by 2.5. Okay, so that will give us the z-score here. So I'm going to take a look, see what we have here. So you got 70 minus 63.6, oops, 70 minus 63.6, I have 6.4 on the top, and divided by 2.5. Okay, let's find out what we have. And I have a 2.56. Okay. So now since the middle is going to be 0 on the standard normal, 2.56 should be on the right hand side. So we are going to draw the line here at z equals to 2.56. Okay, and we're going to shade this area here. So now we are looking for the area P. Z is going to be greater than 2.56. Now, in order to find the area under the shaded area here, we have to go to the table. So I'm going to draw that table over here, and you go down to 2.5, then you will go to the column that will have 0.06. Okay? So we're going to find out what that is. Hang on for a second. Okay. So you go to the 2.56. So that would be 2.56. I have 0.9948. Okay. So the number that I see here, 0.9948. Now remember in class when we use the normal distribution table, all these probability that we found was to represent the area coming from the left. So in other words, that you find this area is going to be always to the left. So if you want to find the area to the right, you will have that you have to subtract that from 1. Okay, so you got 1 minus 0.9948. Okay, let's find out what that is. 1 minus 0.9948, you got 0.0052. So 0.0052, and that should be this shaded area here. So what we're saying here is that in order to join the club, the beanstalk club, and if you go out on the street and you randomly pick one female, and her height's going to be greater than 5 feet 10, is about 0.52%. Okay, so this is equivalent to 0.52%. Right? So that's a small probability there, right? Now, the one thing that we're going to have to be careful is because remember that we are finding area to the right. Okay, if that's the case, whatever the number that you find, the probability that you find from the table, it must be subtracted from 1 because that's representing this right here. Okay, so this area here is 0.9948. But that's not what the area you want. You want the shaded area, so you're going to have to subtract that from 1. Okay, so that was the finding probability. Now let's look at the finding measurement. So in other words, that now we want to find what is a cutoff, for example, cutoff height to become to join the beanstalk club here. Okay, so if you look at this, when you find the probability, you go from normal distribution to the standard normal, right? So now we're going to have to look at the finding actual measurement. You're going to have to go back the other way. So let's just look at this question here. So the weight of the contents of a cereal box are normally distributed with a population mean weight of 20 ounces and population standard deviation of 0.07 ounce. Boxes are in the lower 5%, do not meet the minimum weight requirements, and must be repackaged. What is the minimum weight requirement for a cereal box? So we want to know what will be the box weight. Okay, the lowest. Okay, 5% that do not meet the requirements, right? So I'm going to draw this. So you got mu equals to 0, sigma equals to 1. Now lowest 5% means this is going to be on the left hand side, because if you go to the right, that would be highest, right? So this one here is going to be the lowest, 5%. So if you convert this into the area, that should be lowest 5% means a 0.05. Okay, so we need to know, first of all, cut off a z-score here. Then we will have to go to a normal distribution, right? Then same thing, we'll have a lowest 5% here, and this will give us the actual cutoff scores here. And we know that the population mean mu, okay, let me just, I'm going to erase this. Okay, let's go back. Okay, so we will have to find the population mu. It's already given there, right? It's going to be 20 ounce, and the population standard deviation is a 0.07. Okay, so here we're going to have to find out what the z-score is. So you need to go to a table. Okay, now at this time we're going to have to find the probability. You're not going to have exactly 0.05 most of the time, but we're going to have to find the one that's very close to 0.05. So since this is on the left, we're probably going to go to the negative z-scores. So if you go to 0.05, I have minus, okay, this is a 0.005, right? 0.05, oh sorry, I'm just gonna, okay, so 0.05. Okay, so if you go there 0.05, it will say minus 1.645. So now the z-score is going to be minus 1.645. So this kind of will go, you would say, I would say minus 1.65, so you go minus 1.6, this will be 0.05. Now, if you use the table that we used in the class, you might not get that. It will give you kind of the line that goes all the way to the bottom. It will give you the z-score minus 1.645. Alright, once we find the z-scores, we will go back and we need to find the x-scores, right? So now in this time, the conversion factor is going to be x equals to mu plus z times the sigma. So here the mu equals going to be 20 plus now z minus 1.645 times sigma, in this case is going to be 0.07. Okay, so that will give us the cutoff scores of the minimum weight of a cereal box there. So let's multiply this. Okay, times 0.07, okay, and times 20. Okay, wait. Okay, times 0.07 plus 20, I get about 19.72 ounce. Okay, so I got 19.72. Okay, let's see. Let me do this one more time here. If you do, if you're going to use the 1.65, then you will get a little bit different numbers here. That will be fine though. Okay, you'll get about 19.88, but either way it will be fine. So now the cutoff scores here. Okay, it will be 19.72 ounce. Okay, so whenever you select the box, and if it's going to be less than 19.2 ounce, okay, and then we will have to repackage this, okay, because it's the lowest 5% of the cereal box there. So I just need to make sure that when you finding probability and finding measurement is going to be a little bit different here. So you need to determine when you look at it whether you are finding the probability distribution or you are finding actual measurements. Okay, so if you're going to find the distributions, then you will have to make sure that if you are finding area to the left, you just find the area from the table and use that as your answer. But if you are finding area to the right, like shaded to the right, then you have to subtract from 1 because all the numbers that you see in the box in the table are written for the area shaded to the left. Okay. If you do want to find the actual measurements, make sure that you use the correct formula there. So you will be given the probability, and make sure that when you go to the table, you find the probability that is closest to the probability that you have. Okay, and then that will be the z-score. Then plug that into the formula, then you will find the cutoff scores in this case. Alright, thanks for watching. I'll see you in the next video. Bye.